In this video, we're going to do what we typically do for these practice videos, and that is I'm going to present some problems that go over some of the topics that you reviewed this week, give you a chance to try them yourself, and then once you've answered and play pause it, the video will continue, and I will demonstrate a correct method of figuring out what the correct solution is. So for your first problem, Mara sells balloon animals. She uses the same number of balloons for each animal she makes. The table compares the number of balloon animals sold and the remaining number of balloons on a certain day. And so you have the table of information here. How many balloons does Amira use for each balloon animal? So take a moment, see the information you have here, and see if you can come up with an answer for this. Well, for this, balloons per animal is the rate of change, which is the slope. So essentially what they're asking you to more or less do is figure out the slope for this in balloons per animal made. And, so I'm going to look to see what the slope is. Now what you see here is that the number of animals is changing in the same manner as the number of balloons left is changing. So basically, for every 9 balloon animals being made, the number of balloons that she has is decreasing by 36. So the slope is negative 36 over 9, which is negative 4 balloons per animal, which means that she's losing 4 balloons from her stockpile at every animal she makes, which means that's how much it takes her to make an animal, one of these animals. So basically, for each balloon animal, the number of balloons left decreases by 4. Therefore, each balloon animal requires 4 balloons. Try this one. Isabella filled her pool with water at a constant rate. The table compares the remaining volume of water left to fill the pool in liters and the time since Isabella started filling the pool in minutes. How much water does Isabella need to fill her pool? So take a moment, study the table, and answer the questions, and then we'll go over it. Well, for this one here, again, how much water does Isabella need to fill her pool? So essentially, what we like to try to do is backtrack and figure out, okay, when we have no minutes, how much water is left to fill the pool? Because that's how much water she evidently put in. Because at 2 minutes, she has 184 liters left. At 7 minutes, she has 94 liters left. At 12 minutes, she only has 4 liters left. So, obviously, before she starts filling the pool, she's going to need, that's going to be the number of liters she needs to fill, and that's going to be how much water she needs to fill her pool. So essentially here, we're looking for the y-intercept of essentially this function. So if I'm going to let time be my x's and water be my y's, I'm going to figure out what the slope is, and the slope is negative 18, which basically means it's going, the amount of water needed to fill the pool, or the amount of water left that needs to fill the pool, is going down by 18 every minute. And so I have y equals negative 18x plus b. I take one of these as an ordered pair, so I chose the 12 and 4. So when x is 12, y is 4, and I'm going to figure out what b is. B is 220 liters. So that's how much was needed to fill the pool when she just started filling the pool. So this is, we know that how much water is needed to fill the pool. We need to find y when x equals 0. And therefore, that's 220 liters are needed to fill the pool. We don't know if that's how much the pool would hold, because, we're assuming that, that would be the case if we're assuming the pool was completely empty when she started filling it. She could have been filling it because it had a leak or something and it needed to be drained or whatever. So, but just for this one instance, it took 220 liters of water to fill the pool in this situation. Rip Van Winkle has fallen asleep for a very long time. The length of his beard in millimeters as a function of time in weeks is graphed. How fast did Rip Van Winkle's beard grow? What was the length of his beard when he started sleeping? And you have this graph here to try to answer those questions. So by interpreting this graph, can you figure out the answers to these questions? Well, for the first one, how fast did Rip Van Winkle's beard grow? How fast is asking for a rate of change, or a slope. So if I can find the slope of this line, that's going to give me how fast his beard is growing in millimeters per week. So I find a couple of reference points, and I look. These are points that the graph crosses through where the grid marks are intersecting each other. So this would have been another good point if I chose it right here. But these two are good points. So with that, these 2 points, I move up 25 when I move right 10. So 25 over 10, or 2.5, is the slope. And therefore his beard is growing 2.5 millimeters per week. So what was the length of his beard when he started sleeping? Well, for this question here, you get to interpret, well, where on the graph is that going to be represented? Well, when he started sleeping, that means that the time in weeks of his nap is 0. He just started sleeping. So what we're looking for is we want to find the length of his beard when t equals 0 weeks. So at 0 weeks, we're right here. We're looking for the y-intercept at 10. So here at 10, that's the length of his beard when he started sleeping. So Rip Van Winkle's beard was 10 millimeters long when he started sleeping. Let's move on to the next one. Emir drove from Jerusalem to the lowest place on earth, the Dead Sea. His altitude relative to the sea level in meters as a function of time in minutes is graphed. And you're asked 3 questions here. What was Emir's altitude at the beginning of the drive? And so this is the length of his drive. So we could say that, it starts when he was in Jerusalem and it ends when he's at the Dead Sea. So what was his altitude at the beginning of the drive? How long did it take him to reach sea level? And how far below sea level is the Dead Sea? So, try to see if you can interpret this graph and answer these 3 questions. So for the first one, what was Emir's altitude at the beginning of his drive? Well, at the beginning of his drive, he hasn't moved yet. So basically the time he's traveled, the time he's traveled is no minutes. So at the beginning of his drive, we know that t equals 0. So this would be the y-intercept, which is right here. And if I look at this graph, I have to kind of make sure I know how things are scaled too. On the y-axis, I move up 1, 2, 3, 4, 5 spaces. 5 spaces equates to 200 meters. So every space would be 40 meters. So if I go 1 space above 400 here, this would be 440 meters. So his altitude in Jerusalem, above sea level, is 440 meters. How long did it take him to reach sea level? Well, sea level means, and that's when you're measuring altitude. It's how far above or below sea level you are. And since his altitude was 440 above sea level here, that means sea level is an instance where the y coordinate is 0. So we want to see where it crosses the horizontal axis right here. And as we can see, it crosses right here. I'm looking for the x-intercept. And the x-intercept is right here. When technically the t-intercept, we could call it the x-intercept, the t-intercept, doesn't matter. But I'm looking for this here, and I go along with when the time was 40 minutes. So it took him 40 minutes to reach sea level. How far below sea level is the Dead Sea? Well, we can see where his drive came to an end. He stopped traveling at the end of the graph. And we can see here, it's the end of this, it's the other end point of this line, which is down here, and I can see that goes along with the y coordinate of negative 400. Now the negative just means it's below sea level, so how far below sea level is the Dead Sea? I didn't write it out here. It's 400 meters below sea level. I didn't write a special thing for that, but you can see right here it's 400 meters below sea level. You can do the same kind of interpretation with a equation as well. So when Quinn got home, he turned the air conditioner on. T of T models the temperature in Quinn's home in degrees Celsius. So the big T stands for temperature after T minutes. So T is the number, little t is the number of minutes. And you have this function here. What was the temperature when Quinn returned home? So take a moment, figure out how you would interpret this, and give an answer, and then we'll go through it. So we're looking for a specific temperature, so we want to figure out what this value is. And we want to figure out what happens when he first returned home. Now, remember that this little t stands for the number of minutes after he's returned home and turned on the air conditioner. So basically, he walks to the door, turns on the air conditioner, and then little t is being measured there. So when he got home, obviously he hasn't turned on the air conditioner and the time has not started yet. And I have either she, I don't know, it's a he. So at this moment, t does equal 0. So I'm looking to see what t equals 0. So I can either just plug 0 into this, which doesn't take much effort, or I can realize that, well, at t equals 0, that's essentially the t being the horizontal axis variable. So whether you realize if it's basically what they're asking for is the y-intercept, or you just simply say, okay, I'm going to let the time be 0, you would get 42 degrees Celsius, which is that 42 you see here. And that would be the temperature in degrees Celsius of Quinn's home when he first got home. On to the next one. Very similar. At Simple Travel Agency, the price of a climbing trip to Mount Kilimanjaro includes an initial fee plus a constant fee per meter. F of D represents the fee in dollars for climbing D meters. So F stands for the fee, the total amount of money that you have to pay, and D is the number of meters you traveled up the mountain. And so here's the function that describes that. What is the increase in price for every 100 meters climbed? So figure out how you would answer this question with this equation, and then we will go through it. One of the issues with questions like this is that, it's increase in price for every number of meters climbed. They're looking for essentially for the slope, but looking for the slope instead of per meter per 100 meters. And that sometimes, throws some people off because they would say, okay, well, I'm seeing like, this rate of change, this slope here is a price per meter, but we want to know per 100 meters. So there's a couple of methods of handling this. The first method, I'm going to say, okay, well, what's the initial fee? I can figure that out pretty quickly, either by realizing that that's going to be the y-intercept, and this is like basically the slope-intercept form in reverse. This would be your mx, or in this case, your md, plus b. This would be your b value. So the y-intercept would be at, at this point, so that'd be your initial fee, $110. So you're going to pay this travel agency $110 to climb the mountain, no matter how far up you climb. I can just pick a number since I'm looking for every 100 meters climbed. If I climb 100 meters, I have to pay $122 by plugging 100 into the exact same formula. This difference here from $110 to $122 is $12. So for 100 meters climbed, it's $12 every 100 meters climbed, so I can figure that out right there. Again, if I recognize this as basically slope-intercept, and I kind of put it more into a slope-intercept form, I realize that the slope is 0.12. But that 1.12 is the change in fee and the change in meters. So this is basically 12 cents per meter. So I got to figure out what happens per 100 meters. So I'll kind of set this equal to a fraction per 100. To go from here to here, I multiply by 100. So to go from here to here, I multiply by 100. And when I do that, I get $12. So in either case, I get this $12 per 100 meters. So every 100 meters climbed causes the fee to increase by $12. On to the next one. Now here you're comparing two functions written in two different ways. So in some of these you have a formula and a graph, a formula and a table and a graph. And you're asked specific questions about these. So you're going to be asked this question one at a time, and we'll go through it after you answer the question. So for this one, which function decreases faster? So we're looking for one that has a steeper slope. So, we can see that this is decreasing here. As we move from left to right, it is going down. This has a negative slope, which means it too is going to be moving down as I move from left to right. So I just got to figure out which one's steeper. Essentially, which one has, forgetting about the negative, a bigger value in this position here. Or if I want to look at include the negative, which one is more negative? Which one would be further to the left on a number line if I put those two numbers next to each other on a number line? This one's pretty easy to figure out the slope because this is slope-intercept form. The slope is -3/2. You should be able to pick that up pretty easily. This one here, I have a graph, so I got to figure out, how to find its slope. I could either, pick some specific coordinates, or I could just look at it and say, okay, like if I go from here, which looks like about the y-intercept, to this point right here, which is another nice spot it seems to be passing through the grid, going from here, I'm moving down 2 and right 1. So this slope is actually -2. -3/2 and -2, this one is more negative. It's the same thing as -4/2. So this one has a bigger number for the negative, which means it's more negative, it's steeper. So as a result, since this one's steeper, this function is decreasing faster, it's g. For this one here, which function has a greater y-intercept, which means one that's higher up on the y-axis. So I got to figure out what that is. In this function here, it's written in slope-intercept again. This would be the b value for the y-intercept. So, or I could just realize that the y-intercept occurs when x is 0. So f of 0 would be -1. Q of 0 is -2. So you have these two values here. So which one has a greater y-intercept? Well, the greater y-intercept will be the one that's further up on the y-axis. So that makes that this one is further up, because if you look at another graph here, here's -2, here's -1. -1 is above -2, so this one has a bigger y-intercept. So in this case here, since -2 is less than -1, f has the greater y-intercept. Which function increases faster for the last one? Well, again, if we're looking for like how fast or slow one's increasing or decreasing, it's asking about the slope again. So I got to figure out what the slope is. So when I look at the table, it seems that I move up by 0.75 in the h value every time that t increases by 1. So the slope here is 0.75. This one down here, when I look at the slope, I took 2 points of reference, I move up 3 and right 4, the slope is 0.75. They have the exact same slope. So they're both increasing at the same rate. That means that more than likely, since this one's at -6, this one's at -6.5, this one's always going to be above the other one, so it's always going to have a higher value. On to the next one. So now we're doing more of a word problem. We're going to give you one function in one form and one function in another form and have you compare them. So you're given this long, Thor and Zeus strike with their hammers. The higher they raise their hammers before they strike, the louder the sound of the strike. The following equation gives the loudness of Thor's strike in decibels as a function of the height from which he strikes in centimeters. So height in centimeters, loudness in decibels. This graph to the right gives Zeus's loudness of his strike in decibels as a function of the height from which he strikes in centimeters as well. So this one's being described, Thor's is being described with the equation, Zeus's is being described with the graph. Given these two pieces of information, you're asked two questions here. Whose loudness increases more per additional centimeter of height? Whose strike is louder when he strikes from a height of 40 centimeters? So take a moment, answer these two questions, and then we'll go through the answer. Well, to answer this question, I'm going to give myself a little bit more room here. we know that, what these stand for. I mean, the S on this and the y-axis on this stand for the same thing. The X on this and the H on this stand for the same thing. So I'm just going to look at these two and say, okay, well, Thor's loudness is being described with respect to height with this formula. Zeus's loudness, which is y, is being described with respect to x, the height in centimeters on this graph. Whose loudness increases more per additional centimeter of height? Anytime you see, like, something per, you see that magic word per, or for each, or something along those lines, they're asking for a rate of change or the slope. So basically they're asking us whose slope is steeper. Obviously this shows the rate of increase for Zeus's loudness for each height, different, each centimeter of height difference. We want to figure out the same thing for Thor and Zeus and compare the two. For Thor's, I could see that this is the slope. This is essentially a slope-intercept form. If I let this be y and let this be x, it's the slope-intercept form. The slope here is 3. So Thor's increase is 3 decibels per centimeter height. Zeus, I'm going to pick a couple points of reference. This point and this point here, if I follow the way this thing is being marked, when I move 2 spaces horizontally equates to 10 centimeters. Equates to 3 spaces upward. Well, each space here upward stands for 10 centimeters. So this is, I'm moving right 10 and up 30, or 30 over 10 is my slope. 30 over 10 is 3. So Zeus's loudness increases 3 decibels per centimeter of height as well. So you have to say that the loudness of both Thor and Zeus increase at the same rate. Now, just because that happens, it doesn't mean they're going to necessarily have the same loudness. It just means that, as Zeus raises his hammer higher and, gets louder, well, so does Thor at the same rate. Whichever one has, one's going to be louder, one could possibly be louder than the other, but all the time. So what I want to figure out is, okay, at the height of 40 centimeters, which one has a louder value? So I'm looking for see which one's bigger, the Y value for Zeus or the S value for Thor. For Thor, I just plug in the centimeters, and I get 145 decibels. For Zeus, I look at 40 centimeters, and that coincides. Now again, I'm going by 10 each time I move up one of these spaces, so I'm moving up about halfway. So I'm moving up 5, or take that back, moving up 10 and 5 more, so about 135 decibels. I say 125. It's going to be 135 down here, but it's still smaller. So let me fix that really quick. That should say 135. So with that being said, Thor's strike is always going to be louder because initially, it's always going to be higher up than Zeus's. But anytime Zeus increases his, Thor increases his by the same amount by raising his hammer higher. So it doesn't matter what this would have been. It's could have been any number of centimeters whatsoever. They still would have had, Thor would always have a louder strike than Zeus at the same height that they raised their hammers. So in this case, Thor's strike is louder than Zeus's strike from the height of 40 centimeters above the ground, and everywhere else too. Moving on to the next one. Sean and Mariana start drinking their slushies at the same time and tried to drink them as fast as they could. Sean started with 300 milliliters of slushie, and he drank 5.5 milliliters per second. The graph of the remaining volume of slushie in Mariana's cup in milliliters, as a function of time in seconds, is shown to the right. Based off of this, the description that Sean has here, and the graph describing Mariana's drinking of her slushie, who drank their slushie faster, and who finished drinking their slushie first. So take a moment, see if you can interpret these graphs and figure out these answers, and then we'll go through it. So who drank their slushy faster? We're looking for. You have to be careful about that. I mean, some people interpret it as who drank it faster as who finished first. So they're asking the two different questions here. Faster it means like who's drinking more slushy per gulp or per second in this case. So I'm looking essentially for a rate of change. I'm looking for a slope. So Sean's rate was just given to us. He's drinking at 5.5 milliliters per second, which means that in his cup, the amount of slushy that's in there is decreasing 5.5 milliliters for each second he drinks. Her slope I can interpret from the graph. I find two good points of reference, and I see, like, if I look at right here, her amount of slushy in her cup is going down by 10, down by 50 for each 10 seconds she drinks. So it's going down by 50 milliliters every 10 seconds she drinks, which means that her slope is -5, or that she's drinking hers at 5 milliliters per second. And so since Sean has a higher rate than Mariana, he's drinking his faster. So Sean is definitely drinking the slushy faster. Does that mean he'll finish? Well, that will depend on, looking at the fact that, if they had the same number of milliliters to start with, then, yeah, if he's drinking faster, he's going to finish first. But if you look really carefully, he's starting with 300 milliliters of slushy. Looks like she's starting with 250. So she has 50 less milliliters than he does. That means that she basically has a head start. Now, is his 5.5 milliliters per second fast enough to catch up and pass her and finish first than her 5 milliliters per second? Well, let's find out. What I want to do for both of these cases is figure out, okay, based off of the information that we have, how long is it going to take for the number of milliliters in their cup to be 0? For Sean, it's a little bit more work. Basically, given this, if he starts with 300 milliliters of slushy, that means that's essentially his B value. This is his slope. So what I did, it was like actually one more step that I had there. I kind of thought of his, we'll just say Y value is equal to -5.5 t plus 300. And I looked at this when there's nothing left. And so I started solving that equation, which is how I got 5.5 t equaling 300. And if I divide both sides by 5.5, it would take him 54.54 repeating seconds to finish his slushy. Mariana's is kind of easy to see because I can see right here, she reaches 0 slushy at time 50. So, looking at when they start drinking, she finished hers in 50 seconds. It took him 54 seconds. And that was because he had more slushy to start with. But as the case may be, Mariana did finish first. So, because she had less slushy to begin with. This next requires you to graph, so you'll be given some choices of graphs to look at. Elon sat on the deck of with his fishing rod, when suddenly he felt the rod being pulled down. He reeled in his catch, causing it to ascend at a constant rate of 0.1 meters per second. When it reached the water's surface, after 35 seconds, Elon found that it was only an old shoe. Graph the relationship between the shoe's altitude in meters relative to the water's surface and time in seconds. So take that description, see if you can draw a line that represents that, and then we'll go through it. Okay, so you chose your choice of line. Let's see which one was correct. First, you're being told that this catch, which is actually a shoe, is ascending, which means rising, at a constant rate of 0.1 meter per second. That basically means that my slope is 0.1 or 1/10. This 1/10 might be more helpful because I can see that I do have like single units here. I do have going by 5s here, but I can also go by 10s. So that might be helpful to me. The slope isn't going to help me graph anything, though, until I have a point that the line passes through. So I need to find a coordinate that's given to me in this information. When it reached the water's surface, it was 35 seconds. Basically, it took 35 seconds for it to reach the water's surface. Now, the water's surface would have an altitude of 0, because I mean, this altitude is measured in meters above or below the surface. Obviously, this shoe was underwater. So at 35 seconds, he's at 0. And so I have this point here at 35, 0. Now that I have a point on the graph, I can actually use the slope to find more points. And this slope says I move up 1 and 10 to the right. So I'd go up. Now 1 is 2 spaces. 10 to the right is 2 spaces. So up 1, right 2, or up 2, right 2, up 2, right 2. I can even move up 1, right 1, because that would be up a half, right 1, or right 5, and a half divided by 5 is still 1/10 as well. So I got to put these other points in here as well to help me out. But essentially the graph, when I connect the lines, would look like this here. And that was the choice that you needed to choose. The next one, you're going to be writing the formula based off of the description. So Carolina is mowing lawns for a summer job. For every mowing job, she charges an initial fee of $6 for each hour of work. Well, she charges an initial fee plus $6 for each hour of work. Her total fee for a 4-hour job, for instance, is $32. Let F of T denote Carolina's fee for a single job, F measured in dollars, as a function of the number of hours T it took her to complete it. So write a function for this, and then we'll go through it. So, again, we have to come up with information. I mean, for us to write this, we're assuming that these are still linear functions, and since it is a constant rate of $6 for each hour of work, it is going to be linear. So I need to figure out a couple of things about this. Now, she charges an initial fee. They don't tell us what that is. That initial fee means that if she hasn't done any hours of work yet, this is what the charge would be. So I have to realize, okay, I got to figure out what that initial fee is eventually to write the formula. And sometimes they'll even ask, well, what was her initial fee, you know? She does charge $6 for each hour of work. That's a rate of change. That means that's her slope. So essentially right now, you know I need to find the y-intercept. I have the slope, but I also have a point that the line passes through. And I need to have the slope and at least one point the line passes through to write the equation of a line. If I just have 2 points that it passes through, I could calculate the slope, and therefore I could still find the equation of the line as well. But I need to know what a way of finding the slope, and I need to know at least 1 point the line passes through. And since the line is going to compare the time it took her to mow and the fee charged, this ordered pair is a point on the line. So basically, I have an ordered pair of 432. So my function f of t is going to be in slope-intercept form. I'm just taking x, I'm replacing x with t, and I'm replacing y with f of t. I know that the slope is 6, because we figured out before. I know that I do not know what b is, but I do need to figure it out. So what I'm going to do is I'm going to take this ordered pair that I have up here. This is my f of t value. This is my t value. So I'm going to replace t with 4. I'm going to replace f of t with 32. So I end up with 32 equals 6 times 4 plus b, which is the same thing as 32 equaling 24 plus b. And that means that b would equal 8. So the function's formula for this instance would be f of t equaling 6t plus 8. On to the next one. Harry owes the bank money. To repay his debt, He paid $150 back to the bank each month. After 10 months, his remaining debt was $6,900. What was the original amount of Harry's debt? And how long did it take Harry to pay back his entire debt? So take a moment to figure out how you would determine these things, and then we'll go through it. Well, there's different ways to take care of this thing, but oftentimes if you're asked multiple questions, it is good to have a formula that represents the situation. So all you have to do is just plug different values in depending on what you know, and you can figure out, from that equation what the other value is. So I'm going to create a function where x equals the number of months, and y is going to represent the amount of Harry's debt. So I'm going to just keep this in x and y format. I do know he's paying back $150 to the bank each month. So y is going to be the amount of Harry's debt that's left over after each payment. X is going to be the number of months or number of payments. So the function so far is going to be y equals negative 150x plus b, where b would be the original debt because, again, if I let x be 0, that should be what we're starting with. So that means that no payments were made yet. No months have gone by on his debt. So if I figure out the y-intercept, I can figure out what Harry's debt is. So now I do need to have an ordered pair for this function to figure out the rest of it, and I do. After 10 months, his remaining debt was $6,900. That means that I have a point. If I were to make a graph of this, it would be at the coordinates 10, 6,900. So if I go to this function I started with and replace x with 10 and y with 6,900, I would get that b equals $8,400. And that is his original debt. So figuring out the original debt also helped me figure out a function for this situation here it's being described. And I'm going to use that function to help answer the question, how long did it take Harry to pay back his entire debt? So I have this function, this linear function, y equals negative 150x plus 8,400. We're looking for how long it takes. When I look at the two variables I have, x is the number of months, y is basically the amount of Harry's debt. So that would be in dollars, this is in months. When I say how long, I'm not going to answer that in dollars, I'm going to answer that in months. So obviously, we're looking for x. So we got to figure out, well, what's y in this instance? Well, if he pays back his entire debt, y would have to equal 0 because his debt at that point would be nothing. So I'm basically going to set this right-hand side, negative 150x plus 8,400. I'm going to set it equal to 0. And so I would subtract 8,400 from both sides, divide both sides by negative 150, and I get x equals 56. So based off of this, it took Harry 56 months to pay back the entire debt. Let's look at one more problem like this. A battery was charged. When the charging began, it was 23% full. After 30 minutes of charging, the battery was 89% full. How fast was the battery charged? How long did it take the battery to be fully charged? So take a moment here, make sure you're interpreting these questions correctly and that you're using the information in the problem correctly, and then we'll go through it. To answer both of these questions, it would be a good idea for me to have, components of, if not the entire, function that describes the situation in front of me. So, because we're asking about how fast the batteries are charged. Now, one of the things you have to be careful about when it says how fast, it's looking for a rate of change. Essentially, it's looking for a slope. There are some people, when they ask how fast, they'll answer, well, how fast is the battery charged? They'll say 5 minutes. Well, that's how long it took to be charged. It's not really answering the same question. So in math, be sure that you're answering the question that's being asked of you specifically, and not like that you're doing a misinterpretation because of that's what you would normally answer in some situations. But So we're not really given that rate of change. We're not really told, like, when they told us when the charging began, it was 23% full. So with that being the case, at the beginning of charging, that means when no minutes of charging have gone by. We had no minutes of charging go by, it was 23% full. When 30 minutes of charging occurred, it was at 89% full. So I'm letting the x-coordinate represent the number of minutes it's been charging. I'm letting the y-coordinate represent the percentage of the percent fullness of the charge. Since I do have two ordered pairs here, I do have enough to figure out what the slope is. So I'm going to look to do y equals mx plus b. M is going to be 89 minus 23 over 30 minus 0, which gives me 2.2. So far, and this is the y-intercept, because it has an x-coordinate of 0. So I know that the function that describes this charging scenario is 2.2x plus 23. Now with this function, this question is pretty easy. How fast was the battery charged? That's a rate of change is being asked for, and a rate of change is the slope. So the slope is 2.2. Now to remember what these are in. These are in percentages, the y's. These are in minutes. So basically that means 2.2% per minute, and that's the rate. So if I ask how fast is the battery charged, it's 2.2% per minute. How long did it take the battery to be fully charged? Well, the battery is fully charged when it reaches 100% full. So I'm looking for a y value that equals 100% or 100 in this case. So I'm going to take this function here. I'm going to set 2.2x plus 23 equal to 100. I subtract 23 from both sides to get 2.2x equaling 77. When I divide both sides by 2.2, I get that x equals 35, which means to fully charge the battery on this phone, it's going to take 35 minutes. And that is the end of the problems that you are asked to do for practice. If you have any further questions, please make sure to reach out to me. Until next time, have a good day.